on my hand. Okay, so the ideal gas law says this, that PV is equal to nRT.
Does it record voice too?
Yes, it does.
That's cool.
So the amount of gas is in moles, and that's your N.
Okay.
This R is called the ideal gas constant. And it changes depending on how you label your pressure. So there's going to be 4 different ones that you're going to need to know.
So P is pressure?
P is pressure.
Okay.
So P is pressure. V is volume. And pressure can be measured in terms of torr, atmospheres, millimeters of mercury.
Yeah, we learned this.
And there's one other, and now I'm having a mind fart.
It's atmospheric mercury.
Pascals, kilopascals is the last one.
KP.
kPa. Yeah. So all those things are measures of pressure, and depending on what the pressure is measured in, it's going to change what your ideal gas constant is.
Okay.
Because there's different conversions that you can do between these things. So I might as well give you the numbers. This is 101.3 kPa.
ATM is always 1, right?
ATM is 1. Torr is 760. And so is millimeters of mercury. Both of those are 760. So all of those are all exactly the same measurement.
101.3 for kilopascals?
For kilopascals. So all of those are equivalent to 1 atmosphere.
Okay.
Your temperature...
So if you had 202.6 kilopascals, it's equal to 2 atmospheres.
Right.
Okay.
Right. If you had 202.6, it would be 2 atmospheres, right?
Okay, got it.
The temperature has to be measured in Kelvin. So you're going to have to convert. So
add 263 or 273 or something
right,
like that.
Right. So K plus 273.15 is equal to degrees Celsius.
It's 0.15 there.
Yeah, your teacher probably just did that part. Okay. So now let's talk about each individual piece that they have listed here in your notes. So let me go back to your notes. Boyle's law talks about how pressure and volume are related to one another. So I'm going to go back to my equation. So in this equation, everything stays constant except for pressure and volume. So you have PV. So pressure 1, volume 1 is equal to pressure 2, volume 2. That's Boyle's law. So if the pressure goes up, and this has to remain constant.
So if it's P2, V2, it'll be P4, V4?
No.
Okay, I'm completely wrong then.
No.
Okay.
You're looking at the relationship between pressure and volume. So as this pressure goes up, this volume has to go down in order to compensate so you get the same number. So for example, if I start off with this is 100.
Okay.
And so that's your pressure in, I'll just say atmospheres for now. And your volume is 1 liter. And then I change the pressure to, put a point. I change the pressure to 50 atmospheres. Did the pressure go up or go down?
Down.
It went down. So the volume has to go up in order to compensate. Because this multiple has to be the exact same as that multiple.
So why is it P2V? Oh, wait. Is that just like a second variable? It's not...
Yes.
Oh, okay.
You're changing the conditions of the gas. This is the original condition of the gas.
I got it.
It was under 100 atmospheres, and it was 1 liter of gas.
Ratio that was going on there, like the 1 to 2. that's not the case. Okay.
The number has to stay the same.
Okay.
So if I decrease the pressure by 2, then I have to increase the volume by 2.
Okay.
Because 100 times 1 is equal to what?
100.
And 50 times 2 is equal to what?
100.
So you see how that doesn't change?
Yes.
But the pressure itself went down, right?
Yes.
So the volume had to go up. Those two things are inversely related to one another.
Okay,
That's Boyle's law.
Basically, it's whatever you have on one side. If it goes down or up, you have to balance it out the other way so it equals.
Right. So you're going to be given a situation before. So this is the situation before.
So if that went on 25 ATMs, you'd have to have 4 liters to balance it out.
Just.
Okay. I'm just confused, like a little bit. I'm just still.
This is the situation before.
Okay.
This is the situation after. If you let me talk, I'll explain it to you.
Okay.
So you're going to be given 2 numbers. One's going to be the pressure, one's going to be the volume. On the after part, you're only going to be given one of the numbers.
Okay.
So you'll just have to solve for the one piece that is missing.
Okay.
Okay, so let's go to your notes now. He didn't even give you a practice problem. But in Boyle's law, in action, a common example of Boyle's law in action is a blank. I guess it's a piston being compressed.
Yeah, a car or something like that. I don't know. It is something.
So let's look at a piston. Let me go back to the thing, and I'll draw a picture of what's going on there. So I have this cylinder, and I have a piston inside the cylinder. And there is a certain pressure and volume inside that cylinder.
Yeah.
The volume is how much space you have in here. That would be your volume, and then there's going to be some pressure of the gas in there. Okay?
Yeah.
So, if I have my second picture, where this piston is pushed down,
Okay.
right? What did I just change about the system? Did I change the P or the V? What did I change when I pressed the piston down?
Pressure. You added pressure to it.
No. I changed the volume. You see this V2? You see how it's smaller than that V1 there?
Yeah. Well, hold on. Wouldn't the volume just be compressed though?
What did I physically change when I moved this piston down?
The volume.
I changed the volume. Because I changed the volume, there's going to be a difference in the pressure. This is the thing that I directly affected. I changed the volume. I made the volume go down here, right?
Okay.
So because I made the volume go down, I shrank the volume. There's less volume.
There was less gas here than there was there?
No, there's the same amount of gas in both.
Okay.
There's the same amount of gas in both. But I changed the volume, right? So what should happen to the pressure here?
I see. Okay, I got it. So you're just changing the amount of space the gas occupies. You're not actually changing the amount. I was wondering where that gas went. So it's just
the gas.
Just the space
it's sealed.
it occupies.
I'm just changing the space that it occupies.
Okay, got it.
So if I change the volume, if I make the volume less, what happens to the pressure?
It increases.
It increases.
Okay, got it.
So those are the 2 different scenarios for Boyle's law.
That clarified it. Okay.
There's going to be some variable that you change. That's your independent variable, just like in any other experiment.
Okay.
All right. I think it's going to stop me anyway. Okay. So that's Boyle's law. So I'm going to stop this.